Hi, very good evening. My name is Nathan Anthony, and we are going to present our group assignment, which is a control systems assignment. And we are from Group 4. So, our project is about industrial automation. So, well, if you can see, this is our group members. So, our group members are Hari Dharan, Analaki Ravi, Nathan Anthony, myself, Muhammad Alauddin bin Rahman, Muhammad Zakwan Haikal bin Inci Ibrahim, and Jagan Raj Analaki Muthukrishnan.
Hello, my name is Yuvraj. I'm about to present the project for signal and system, and I'm from section 3, group 4. I'm about to present the introduction. The industrial automation leverage advanced technologies like robotic, IoT, AI, and control system to enhance productivity and reduce the cost and errors. PID controllers tuned using technique like vehicle networks or simulating PID tuners play a critical role in modeling, testing, and optimizing control systems. These controllers utilize closed loop feedback and regulate process variables such as pressure to achieve desired outcome in industrial process. The sustainable development goals of this project is being affordable and clean energy. This makes the automation optimize energy usage in manufacturing by reducing waste and improving efficiency. And another one is decent work and economic growth. This increases the productivity and efficiency, driving the economic growth. Other than that, responsible consumption and production. This reduces material wastage and energy consumption through precision manufacturing. Other than that, industry innovative and infrastructure. This also let us maintain the drives innovation through the adaptation of advanced technology like AI and robotics. Finally, climate action. This improves the automated energy efficient processes to reduce carbon footprint and facilitate the monitoring and reduction of greenhouse gas emissions.
Hello, good evening. My name is Haridharan Ravi. My metric number is CE230064. Today I would like to present about the circuit, which is circuit A. The input that I have used is this is the circuit that I have built. So for the input, I've been using the time step with 1 and final value is 1. And for the system process, uh, for accutator, I use the number of 1 and denominator is 1, 3, which is the output is 1 over s plus 3. And for the process, the numerator is 4 and the denominator is 1, 2, 3, which is 4 over s power of 2 plus s 2s plus 3. And I've used the mark with the input type of 2. And the final result I get from the scope is this. This is the final result after I tuning the system. And I continue with the part B, which this is the part B. So I add on the disturbance and subtract the disturbance with time step 1 and the final value is 0.1. So the output that I get after running the system
I will make an explanation and demonstration of Simulink.
is after I tune the system. So my
Open
final
loop
output
for
is
second order.
Hi, a very good evening. My name is Nathan Anthony, and my matrix number is DE220068. So, well, if you can see, the simulation is about open loop second order transfer function with PID controller. So well, if you can see this circuit, there's a step function here, and this is inside the step function and the values of, and this is the PID controller. You can see this is the PID controller inside, and this is the transfer function. Well, you can see we have put the values in, and the numerator's value and the denominator's value, and this is called the subsystem, and inside the subsystem we have to put the equation. So this is the equation right here. Then this is the two scopes for the output. So now we'll run the simulation. So this will be the first output, and this will be the second output for our simulation.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alauddin Rahman. I'm from Group 4. Today I will continue presentation. Okay, this is my circuit. Okay, first component is parameter step. For step, we use 1. Okay, after that, we connect to PID controller. After PID controller, we connect to transfer function. Okay, for transfer function, we use second order transfer function. Okay, next we use a scope. Okay, for scope, this scope will generate a graph what we want. Okay, for the line below, this is a feedback. Okay, all these component you can get easily from library browser. Okay, here. Okay, next I will run this project, and this is the result from this project. Okay, that's all from me. Assalamualaikum.
Hi, very good evening, and my name is Nathan Anthony. So well, in this simulation I'll be explaining the closed loop system of the PI controller. So this is the simulation, and well, in the simulation you can see this is the step function. This is the PI controller, and this is the transfer function, and this is the subsystem, and this is the scopes, and we have added the feedback loop so it can be a closed loop system. So now we will run the simulation, and after we'll run the simulation, this will be our first output, and this is our second output. This is how our second output looks. Hi, very good evening, and my name is Nathan Anthony. So well, in this simulation I'll be explaining the closed loop system of the PI controller. So this is the simulation, and well, in the simulation you can see this is the step function. This is the PI controller, and this is the transfer function, and this is the subsystem, and this is the scopes, and we have added the feedback loop so it can be a closed loop system. So now we will run the simulation, and after we'll run the simulation, this will be our first output, and this is our second output. This is how our second output looks.
Assalamualaikum and very good day to my lecturer. My name is Muhammad Zafran Haikal bin Ibrahim. Matric number 88230004. Today I would like to present about the simulation. First of all, we go to the first simulation, which is legal open loop. So you can see this one. This is a step input. The step signal is provide as the system input negative for testing response characteristic. So after that, we go to the gain box, which is this one, K, negative K. Tuning bell gain is introduced into the system, which is labeled as minus K. So we go to the transfer function. So in this transfer function, we have 4 over s squared plus 2s plus 3. So lastly, we go to the output display, and the system response is observed on the output unit. And so for this one, feedback path, this include connection, but it appear to be configuration for an open loop experience. So we can see the graph over here. So this is a graph for open loop. Next, we go to the Ziegler closed loop PID. So you can see this is a step input. A step signal serves as the system input. So summing junction here. The input is compared with the feedback signal to compute the error. So for this one PID controller, the block label PID S represent a proportional integral derivative controller. It adjusts the function of this. It adjusts the control signal based on the error, improving system performance. And then you can see the block diagram, which is 4 over s squared plus 2s plus 3, represent the dynamic of the system being controlled. And then you go the path, feedback path. The system output is feedback into the summing junction, forming a closed loop system. And then output, this one is output display, the final output is monitored. And then you can see the graph over here. So this is a graph for closed loop PID. And last but not least, we have a Ziegler closed loop for gain, which is this diagram represent a feedback control system commonly used in control theory and engineering for stability analysis. So you can see we go to the input signal, which is square wave. On the left side, the square wave icon represent the input to the system. This could be a test input such as a stat signal used to analyze the system response. And then you can see the simulation summation block. You see this circle one have plus and minus. The circle with plus and minus represent the summation block, where the input signal is compared to the feedback signal. The output of this block is error signal, which is the difference between the desired output set point and the actual output. So for this one proposal, we call the proportional gain triangle with 1. The triangle with label 1 represent a proportional gain block in the specific diagram. The gain is set to 1, meaning the error signal is passed unchanged to the next stage. So after that, we go to the transfer function block, which is 4 over s squared plus 2s plus 3. This represents the plant or the system to be controlled. This transfer function characteristic the dynamic of the system. And this one for the feedback loop, the line going from the output back to the signal input summation dot represent the feedback loop. The output is feedback and compare with the input to adjust the control action. And lastly, output display, which is this one. The monitor icon on the right represent the output display, where the system is response can be observed and analyzed. You can see this is the graph for closed loop gain. So that's all for me. Thank you.
The discussion of this video is about comparing the Rieger-Nicol and Simonic PID tuner method for designing PI and PID controller in closed loop system. Rieger-Nicol offers quick tuning but may result in steady state error, while Simulink PID tuner provides a simulation-based intuitive interface for precise adjustment. Both methods are evaluated based on transient response, steady state error, and the choice depending on system requirement and the balance between speed and accuracy as well. In conclusion, the study explored designing and tuning PI and PID controllers using Rieger-Nicol and Simulink PID tuning methods. Open loop analysis provides insight into system dynamics. The closed loop analysis highlighted the effect of PPI and PID controllers on stability and steady state error. While Rieger-Nichols offers faster transient response, it may result in a higher steady state errors. The Simulink PID tuner with real-time adjustment proved more robust and user-friendly for handling disturbance and error as well.